want to welcome people today to the Project WiCCED seminar series. And my name is Kent Messer. I'm the project director of Project WiCCED. And as I was talking with Dan and Tina, I know this is a crazy time in most of ours schedule right now, with the first week of the semester coming back, at least at the University of Delaware, which means that we're balancing a whole bunch of new agendas and changes in times and so forth. So I appreciate you being here and welcoming off the spring semester. I do want to just kind of make some brief announcements about upcoming speakers. You can see the flyer coming up. Again, we're going to try to do this every month and gather at this time and hear from the various research people and education outreach and all the partners that are part of Project WiCCED, so that we can keep abreast of the work that's happening by our colleagues in this project. And of course, always welcome our students and our grad students and partners to attend these seminars as well. But they're a great way of communicating, especially at a time where it's difficult to do these in person. We'd all love to do them in person. We'd all love to be able to connect in on a friendship way and a colleague way. But alas, that's not possible. So I do appreciate people participating in this seminar series. And today we're really, always happy to learn from what is happening with the DataCore, right? And that's being so aptly led by Dan and Tina and their teams, really one of the stars of Project WiCCED. If you weren't part of the Darwin discussions last week, they represented our team very well, along with Jing and Shan. We're all there talking about the various data science related efforts that are connected with Project WiCCED. And so we appreciate their continued efforts in this project, along with their reaching out across to the data science world, which is so prominent in Delaware and throughout our region. So we're going to be hearing today about the DataCore, from data to decisions. And Dan, I'm going to pass it on over to you.
Okay, thanks a lot. And I think that Tina will need to share her screen and put the slides up. She's going to be driving the bus this morning as far as the slides are concerned. And so I just wanted to start out by saying thank you all very much for the invitation to come and talk about what's happening right now with the DataCore. And you can see the title here, it's from data to decisions. And what you end up finding out is there's a big gap between just getting data and then helping people to make decisions. So if, hold on one moment, please.
Give me just a second here. Apparently I clicked, everything goes well until everybody's watching, and then, okay.
Well, I thought we were going to be watching some video game there. I thought that Dan was going to show us a weather decision-making tool that's now an app for the Apple. That would have been pretty great.
Right, exactly right.
I thought that was my computer, Tina. So I'm sitting here trying to get rid of that thing, and then I realized it was on your end. But all I wanted to really say to begin with is that the title data to decisions, it seems like that should be a really easy connect there. But what we're going to be talking about a lot today is there's a lot of steps in between there. And so if you can go to the next slide, Tina. So Delaware's water environment, if you stop and think about it for a moment, Delaware's identity is really water in many ways. We sit on the Delmarva Peninsula. We're surrounded on one side by the Chesapeake Bay and the Delaware Bay and the Atlantic Ocean. And if you think about how much of Delaware is really identified with water, the top picture there, commerce in Delaware, really with the port of Wilmington. If you think about how important water is in agriculture, which is a huge industry in Delaware, tourism, the scenic nature of water, with that beautiful picture there of a Delaware beach, recreation, all of these things are what I think people really think about when they think about Delaware. And that's great. And that's one side of the coin. But if you can go to the next slide, Tina, the other side of that coin is that even though we're identified with water really, and it's so important in our state, that also leads us into possibilities of a lot of problems. And you can see some of those problems here that are associated with water. We have both inland and coastal flooding issues, which are huge concerns in Delaware. That goes along with sea level rise, which is, just something that is pervasive really in people's thoughts across the state. We have saltwater intrusion, not only affecting agriculture, but affecting the wells and groundwater in the state. We have harmful algal blooms. And we could go on and on. I mean, with the first slide, we could have said a lot more about how important water is to Delaware, but we could go on and on with potential water security issues for Delaware, like you see on this slide. So it's really two sides of the same coin. And if you could go to the next one, Tina. Now, we're lucky in Delaware because we have, I would argue, one of the best monitored environments in the entire world, really. I would put us up against any state in the United States for the number and the quality of environmental observations that are taken. The map that you see there is really just showing some of the different sites where either continuous or in some cases non-continuous observations are being taken of all facets of our environment, whether it's meteorology that you see there on the left-hand side of the screen, meteorological variables. We have the highest resolution statewide network in the country. We have great water quality monitoring across the country, across the state, both continuous and also with grab samples, as you see there in the upper right-hand side. And I could go on and on with all types of monitoring that DGS, the Delaware Geological Survey, does, DENREC, and a lot of the other people that are on this call. I realize there's all of us, so many of us are doing environmental observations. In the lower right-hand side, I also didn't want to forget that we do have a satellite receiving station here on campus. We're bringing in polar orbiting and geosynchronous satellite data. And so we get a lot of satellite and remote sensing data for the state as well. So we're really well primed as far as data coming into the state. But the problem with that is we eventually want to go to the slide you see here, decision support systems. And the problem with all the data that's coming in is that for users and people who are going to be making policy and people who are trying to make decisions, whether real-time or long-term decisions for the state, number one, they're not sure where to go to look for the data that they need. And even if they know where that data is, many times it's in a form they can't use, and it hasn't been integrated with other pieces of data to really come up with a system that helps them in their work, helps them to define policies for the state or to make quick decisions about evacuations along the coast or whatever it may be. And so there's a real process getting from just collecting data to decision support systems like you can see here that are hopefully helping people to make decisions. And these are two of them that SEMA have done. I don't want to just concentrate on SEMA today because this is not just about SEMA, but it's about everything that's available in the state, again, including Delaware Geological Survey, DENREC, many different state agencies, and even some of you folks here on this meeting today will have your own decision support systems that you've been able to put together and make available to people. But there is a process, and that's what this slide shows. So over there on the left-hand side, you can see that really in the process to get to decision support and then to be able to help the state practitioners and so on, you need to start out with that big piece of data observations, both in the field, any type of data that you can think of, remotely sensed data, field data. We have just such a great suite of information coming into us. But then, as you can see in the upper left there, we have the researchers. And that's a lot of what the folks in WiCCED are doing right now is, okay, we have this data coming in, but how can we integrate that data? How can we do better at modeling future events? We have to analyze that data, think of ways to integrate it and put it together in a meaningful way that'll then help to build those decision support systems that are on the right-hand side. And if things are working right, those decision support systems then there should have been a constant interaction with state practitioners, the policymakers, the citizens, that once they, first there should be testing to see how helpful those decision support systems are. But once they start using them, what our hope is that they'll feed back into telling us, well, what's the type of data that we really should be gathering that's going to be helpful to them? And how can we integrate it better? And what can we do to make those decision support systems more useful? And so that's kind of the workflow, so to speak, to get to those decision support systems. And this fits right in with the WiCCED project, which is to assess threats, develop solutions to mitigate human, agricultural, and natural pressures threatening water security in our changing coastal environment here in Delaware. And if you could go to the next slide, Tina. The DataCore then really touches on all the different pieces of Project WiCCED. Certainly, we're interested in any type of data that's coming in from the different threat teams, whether it's a salinization or salinity with the nutrient mobilization or any of the rest of them. We're also very interested in contributing to the solution development. And we're very closely tied to the social dimensions, because it's really the social dimensions of how do we get these decision support systems out there? How do we best create them to be most useful to people, et cetera? And along the way, we really want to do a good job in education, reaching out to communities, bringing in diverse user groups and diverse students, and really build those strong statewide partnerships. So with that, then I will let Tina go to the next slide, and she's going to take over from there and talk a little bit about this whole process.
Thanks, Dan. So given all of that information about where we sit in the Project WiCCED, we as a group kind of sat down and we thought about, well, what does it really mean to be DataCore? And if you think about all the things on the left-hand side here, there's data storage, integration, analysis, and visualization. And if you want to really kind of summarize those, it's talking about we need infrastructure. We need to make sure we manage our data. We have to talk about how those analytics and machine learning and modeling get integrated, and how do we actually get the message out effectively. And all along that while, we need to make sure we incorporate everything that talks about getting that pipeline of talent, or training our students better, and also getting that message out. So that's social dimensions and outreach and education and diversity are key. So Dan, you may want to mention a little bit something here, but what we'd like to do is kind of focus a little bit for the rest here about an example machine learning project that kind of follows a lot of those components that I just outlined.
Yeah, and I'll just say something about this, and then we're going to try to tag team less so that we're not going back and forth. But one of the things that I've been very interested in, and again, one of the big problems in Delaware is flooding, and certainly coastal flooding. I don't want to minimize that in any way, but here in northern Delaware, we have quite big problems with flooding on Red Clay, White Clay creeks, the Christiana and Brandywine rivers. And so one of the things I've noticed in the literature of late is that well, I shouldn't say a lot, but people are starting to get around to start thinking about how can we learn big data techniques or how can we use big data techniques like machine learning in doing some things that we used to do by constructing very detailed physical models. And one of the most complicated types of models you can have is for the response of stream flow to precipitation events. And that's, again, a very, very big deal here in northern Delaware. Both the Red Clay and White Clay creeks and the Brandywine are all very flashy streams. And so what we wanted to ask in this kind of beginning project is, can we take some big data analytical type work along with all this great data that we have and do a good job of modeling the stream flow on a place like Red Clay Creek? And I also just want to mention that the other reason for doing this is that NOAA has this wonderful new system called the National Water Model, which is making forecasts for different stream reaches across the United States, thousands of them. And it's The problem though with this national water model is it hasn't been verified at most locations. And the other thing is that they have limited data inputs. And I won't go into the modeling framework they're using here, but what we really want to do in this project is really evaluate how well that national water model is doing, but also put together our own model of stream flow on the Red Clay Creek and compare that to how well the national water model is doing, with the idea that with our increased amount of data and the higher resolution, the higher temporal resolution, we should be able to do a better job than that national water model, and therefore provide really important information to users here in Northern Delaware when it comes to potential flooding situations. So I'll be quiet and let you take over from there, Tina.
Thanks, Dan. So if you take those components that I mentioned earlier and apply it to this machine learning project, we kind of look at this as a journey. And so again, if you lay out kind of in order all of the different components, what we have is each mile marker to get to our final destination. And so if you look at the infrastructure for Project WiCCED, we really kind of hit the ground hard on this. We tried looking at all of the different resources that we could gather to do the things that we think were needed in order to accomplish this, at least using this machine learning as a good pilot project. We had to talk about hardware, we had to talk about software, networking, access. These are all things that are very complex structures to have to deal with. And then we have to talk about the science. So it's quite a daunting thing, and it's taken quite a bit of back and forth. And luckily, we've been able to lean on the University of Delaware Information Technologies connection to the Internet 2 backbone, which you see those little nodes with the lines going back and forth. Actually, there was a national research platform pilot project where we were able to get in and basically leverage that entire network. So if you imagine that nodes going on to what a geographic map would look like, this is where these nodes are. And so we're talking about getting access to high compute resources across the country and leveraging that to our use, as well as helping them train on what is it that researchers are needing. So we've established that infrastructure, and then we then need to turn to the data. And in this example, Dan did mention, we have the radar data that we'll need to bring in to try to get estimates of what the precipitation would be, observed meteorological data, and then stream measurements of the water flow as well as the gauge heights. And in the end, we had that architecture. We had to get these end users, and the end users in this case were our researchers. They needed to be able to get on there so they could start building their models. And then at this point, the access is very promising to that infrastructure that we discussed. Of course, going back to the analytics and the machine learning, we really needed to figure out, how do we understand that national water model, and what is the result of what is it actually telling us in the forecast? How can we improve what is being said there? How can we use that as a benchmark for what we wanted to build that gives us a higher resolution, or what we may consider as a better return on reality in the terms of the forecasting? So this is the main progress at this point is we do have an initial model. We do want to look at possibly hybridizing that, if that's the term, the idea of just trying to really get to the physical component, the statistical, marrying that with machine learning components, and getting to some product that we can really utilize at a very good local level. And
Tina,
so, yeah.
I just wanted to jump in and say, and that's not just us. I just wanted to give credit where credit's due. This is a lot of people working on this. Some folks from Shan groups and Andy's group, Pat, who many of you know, certainly Matt Shatley in our group. They've all been working on this machine learning case study that we're doing. And so I just wanted to thank them.
Yes. So all of that background work is well and good, especially if you're looking at a more academic exercise. really what we're looking at is kind of really getting into the reality of how can we affect better decision making. So we've been successful with, and I wanted to bring up Pat Zingo, grad student working under Andy Novison, has been able to develop an initial machine learning model based off of the historical data that he's trained it on, that we've pulled in. And we've been able to build a basic web front end where a user can actually go in and give an anticipated rainfall amount. And it uses that machine learning model to produce an output plot where we can get, in this case, this is a 12-hour forecast of where we expect it to be based off of what the user input was. And again, there are all kinds of different uses of why we would want to go with this particular user input option. I think the doors are all open now on where can we go from here. One of the things that I've imagined is, if you look at the destination being having this workflow that's successfully building on a user input that allows us to load the model, request information, and based off of the historical data, get a generated output that can be displayed for someone to understand better of what we're doing. That particular workflow allows us to now look at maybe doing internal testing. Maybe we can build entire internal decision support systems that employ different machine learning algorithms, hybridized models, that we can see what would be the difference between this model and this model based off of what the input is. So there's a lot of testing that's going on there. But then imagining that same thing being souped up and cleaned up in a way that it's a great user experience, taking in the projected information on what is forecasted and trying to see what we see is possibly going to happen on the ground. In our mind, a more reality than possibly what the National Water Model could do. So if you harken back to that the typical decision workflow, you'll notice that I've added a couple components here. We have the machine learning being injected into that modeling and analytics. And now that's increasing our compute needs, as well as a lot of the gears and wheels that are happening in the back end. But as we produce output to build the decision systems, support systems, what we see happening is, you'll see that green arrow, that the state practitioners and the citizens and the end users are actually going to be feeding back to the model. And you could even add in an agent-based model where you see that practices on the ground are actually influencing how water moves. And so now we can start retraining the models, learning about what reality is telling us, and building the models better or tweaking them as we can in a real-time sense. But ultimately, I'd like that little orange box to kind of be happening. And Kent has really helped us start down that road in trying to develop an understanding of what is it that users need? So what do the state practitioners need in order to get their job done? What do the citizens need to do to be more prepared? So as we start to understand, how do they use the information? Can they use the information? What are the devices that they need? What are the decisions that they make? These are all important key things that we need to add into that idealized workflow. And I believe we're really, really well on the way. So just with the last bit here, I kind of wanted to focus a little bit on some of the other accomplishments. Again, that's an example of the machine learning employed using our infrastructure, but we also have, as I mentioned, Kent's been able to help us quite a bit with helping with some of the social dimensions. And so we've had everything from understanding how users are using the applications, doing surveys to see what they would, how they would change. And so the specific example, I think, would be the flooding study that was done. I think there was also one on an app that was developed, but trying to understand in the flooding study that if they see water, would they turn around if they were knowing that another route is there and it's going to be 5 more minutes to their ride, or something like that. So it's understanding what are the decision processes for each individual that's using the applications. In addition, been able to make collaborations. One example of a collaboration, and I invite you all to go out there to develop the Coastal Observer app. And again, this is a citizen science application to try to get people out there and observing their environment, hopefully helping us fill in gaps of data to understand our environment better and what's happening in the spots that are not being monitored. Can we start to take that information and use it? So these people are observing flooding, they're observing pollution or algal blooms, or huge weather severe events, and they're documenting those over time spatially. And this is global. You could do this anywhere. So next time we are all able to travel, you could still use this. And I guess lastly, and definitely not the least, we have been able to develop a pretty good outreach education diversity. We've been able to, through Andy's group, been able to run a couple of really good coding exercises to help train people, train the students. And we're trying to make this even more virtual. I think last spring it was pretty virtual, and I think he's working pretty hard to try to extend that to make sure that we get all of our partner institutions involved. And we can talk about that later if anybody has any questions, but we do have interns that are working with us. We have a connection through Andy's group again to the Aberdeen Proving Ground. We've had, I believe, 5, maybe even 6 now, students actually get gainfully employed with them. So these are all good wins for us as well as them. And then our last thing that I think was a good win is through all of this discussion of data and infrastructure, we needed to lean on each other. So we've been able to establish a student, and I should say, this is actually a faculty and staff work group. And so we're working through the problems and seeing the hurdles and championing things together. So did you have anything, Dan, you wanted to add to the accomplishments?
No, I think you covered them real well, Tina.
Okay. And so I wanted to kind of end with this. And I have to admit, a little shamefully, I got to know this Ben and Jerry's ice cream over the COVID time. And I was in awe when I started thinking about, you know what, this really means something to me when I look at it more than just the ice cream itself. I see DataCore at this. So if you imagine a lot of the stuff that DataCore is doing, we've got the visualization, the pretty stuff on the outside, the outreach and the education, but in the inside, we've got the people, the stakeholders, the threats, the solutions, and all of the data samples, and right at the center. And I have to say the sensors and the microbiome have to be in there too. But I'm talking about DataCore today, so I put DataCore in here. But in essence, this is how I see it. So I thought it was just a cute little visualization to end with. Anyways, at this point, the way I see it, and I know Dan agrees, is that the journey is really kind of just beginning. It continues, and we have a lot of cool things that I think are down the pipeline. And what we see is that we would like to enable everyone else on their data journeys. So hopefully some of the things that we discussed have given you some perspectives on some things, and we'd love to have any questions at all. That's it.
Awesome. Awesome. Thank you very much, Tina, for that. It does look like we have 2 questions right now in the chat, so I'm going to start off. Do you use people's reports of floodings to validate sensors and predictions?
Well, Tina can cover that. The Coastal Observer, that's somewhat what that's for. And so if you want to go back, I guess, Tina, you still have the slides up. If you want to go back to the slide there that has the Coastal Observer, that is one of the things that the Coastal Observer app does. And Tina could explain that a little more. And we have also had, for our coastal flood monitoring system, we have heard through, so the answer is yes to both, I think. But for the coastal flood monitoring system, we've heard from the National Weather Service, the folks that they talk to about how high the flooding is in different coastal areas and so on, that it's been pretty accurate. And so, yes, we do get feedback in that way, but the Coastal Observer app is even better that way. And I don't know if you want to say something a little bit more about that, Tina, or not.
I don't want to belabor it, but I do want to say that there are more. There's more than just the Coastal Observer app that's out there. There's Art Trabanis has actually been able to get a CoastSnap in Delaware started. There are plenty of other citizen monitoring programs that are national and international that are doing all kinds of different observations. At this point, we're not pulling it into the, for the example, the stream flow, that's not going to be using it. But I guess I have hopes that, you know, again, it was just released, I think, last year. So once we start to get to the point where we're getting the submissions that we like in the terms of the numbers and so forth, I think we can start using this and applying this. So if you have any ideas or anything for studies, I'd love to hear them.
Thank you for that answer. Next question. Are your flooding models also applied to denser urban areas like Wilmington?
The answer to that question is right now, no. We go up to Newcastle as far as we go with our coastal flood monitoring system, and that's because of the input to coastal flooding situations from stream flow. We often have inland flooding when we're having a coastal storm, and that's a whole different set of hydrodynamics, but we are working on that. We're also working on it on the inland bays. And I see there that question also has, do the ML models use any transportation or traffic data to assess flooded roadways? And I don't know, Kevin Brinson was on the call, who's been actually working on that with DGS and with DelDOT. Kevin, are you still on?
Yeah, I'm here, Dan.
I don't know if you wanted to say anything about what you've been looking at with flooded roadways and getting that information to DelDOT and potentially putting that into our models long run.
Sure. Just real quick, we have a study we're doing with DelDOT where we've identified about 250 locations or roadways, I should say, throughout the state that are facing some form of flooding issue. What we noted is that the vast majority of them lack any sort of real monitoring that takes place, both for stream monitoring or tides. And probably one of the most glaring lack of data in the state is that sort of timing and frequency and duration of road closures related to flooding. There's a limited database that the Department of Transportation has, but it's currently not constructed in such a way that it can be used right now for many of the hydrological studies.
Well, thank you for your input on that, Kevin. It looks like we've got one more question in the chat. Are there any intentions to partner with the city and or state to use these citizen reports to get them to the appropriate department?
At this point, we don't have any plans. So the first thing that we were challenged with was just getting the app out there and advertised. That was pretty much through the summer and into the fall. At this point, we're having some conversations with NOAA and North Carolina King Tides projects to try to get this this particular application utilized at a much greater volume. So I'm hoping, because the King Tides is a large national initiative from NOAA, that what we'll do is get this in every state. And with that being said, I'm hoping what we'll do is start to see this information is going to be, you know, there's going to be a lot more data to analyze. Secondly, I think that there are definitely some opportunities where we can start to review how the data is helping us, and the API that's in the background gives us lots of opportunities to investigate that. So again, it's just more identifying the problem and what we can do to address it with the data.
And I would just like to add that here in Delaware, one of the things I think that people don't know that we didn't mention today when it comes to getting this information in the hands of the right people is that our decision support systems and our data in general that's coming in real time, we have an alert system that when certain thresholds are reached, for instance, maybe a flood level on the White Clay Creek or a tidal level down in one of the coastal towns, that if the people are signed up, and there's a lot of state people that are signed up for these, the user can get an email or a text message, they get both actually, to let them know that some environmental threshold has been reached. And that can be anything from a wind speed to temperature to stream flow to tidal levels, whatever. And that is being used by the state for, again, to get the information into the right hands. We also are doing flood monitoring for a lot of ponds in Delaware. And I think it's over 30 ponds right now where we have water level sensors. And those are all tied to an alert system as well, so that the appropriate people get that information if the water level gets high, so they can open up the sluices and not have a dam breach. So we do have that system already in place that really does help to get especially real-time information into users' hands.
Can I just comment on that, Dan?
Mhm.
One thing I think is really cool about that from a researcher perspective that people might be interested in is potentially using that to turn on, their sampling instrumentation, or to go down and take a sample, things like that. We recently talked about doing that with some of our instrumentation, which I hadn't thought of before, but I think is a really great application.
Yeah, and we have that all set up. So anybody that would like to have that type of capabilities, just get in contact with us. We haven't made that open to the general public, but certainly to researchers and other folks. And then decision makers are who we usually open that to. But we're happy to have other people on that. And if it can be helpful, that's great.
One other thing that I didn't add was that we have been working with some of the researchers in the project, Project WiCCED, to get their data visualized to them internally. Sometimes it's a battle of, I have a volume of data that I don't want to work with too much in the terms of the nuances of getting it into some kind of graphing format. So that is something that we've been able to do for a couple of the researchers. So again, there's all kinds of, there's a spectrum of visualization that we're discussing here.
Anything else we can help with?
Well, I'm going to throw out one more thing, and since there's a lot of folks with Project WiCCED leadership and researchers on this call, it's good to know the Department of Applied Economics and Statistics partnered with Project WiCCED to recently buy some eye tracking software, and I think this is a good chance for us to get to the points that Tina, you were talking about, the end users. And of course, COVID has really smacked us in the face with trying to deal with things with end users, right? Because that means they're people that we want to observe how they're doing things. Now, if it's an app, we can maybe observe that from afar, but hopefully we'll be able to engage with properly socially distanced and safe ways of doing this. But we do have new software and hardware that is really cutting edge to look at how people are interfacing, right? Where are their eyes going? We design it and we assume that everyone's eyes go to where we think it is. We now have 2 of those units that are being installed in Townsend Hall. And so I'll drop you a note later today, but just saying, let's talk about where would be a good project for it, right? Where would be a good spot? Because I know our graduate students and some postdocs are excited to do that. And again, I think we can get some initial observations even in these conditions now. So yeah, so it's exciting. If there's other connections, let us know.
Yeah, that sounds great.
Okay. Well, we know that it's right before lunchtime and everything. We can obviously know Dan and Tina are super available to have follow-up conversations or emails because they're always available. But I do want to thank us for participating today and look forward to people connecting into the next seminar series. So thank you and be well.